Okay, so today we're going to unpack something super interesting.
Yeah.
You found this research article called A Case for Domain-Specific Curiosity in Mathematics.
Right.
And we're not just talking about curiosity in general, like, are you a curious person?
Right.
It's like, what does it mean to be curious about math specifically,
Uh-huh.
and why that might be a whole different thing?
Yeah, well, that's what's so fascinating about this research is like they're saying curiosity isn't just this on-off switch, you know? It's
Right.
not just like you're either curious or you're not.
Uh-huh.
It can be really, really specific. And I think we all kind of know this intuitively, right?
Yeah, totally.
Like you might be super curious about like how a car engine works,
Right.
but have zero interest in like, I don't know, the history of lawnmowers or something.
Yeah?
Right? And so this article is making the case that the same thing can be true for math.
Okay.
Like your curiosity when it comes to math might have its own rules almost.
Yeah, and this is kind of an interesting angle, too, because
Yeah.
when you think about how people feel about math generally,
Right.
it's not always the most beloved subject,
Yeah.
right? We hear about math anxiety all the time.
Mm-hmm.
So to think that there might be a specific kind of curiosity
Right.
that could make it more engaging,
Yeah.
that could help people actually kind of enjoy grappling with numbers and equations.
Exciting.
Yeah.
That's huge, right?
Huge, yeah. And it's not just about making math more fun.
Right.
The article also points out that understanding this math-specific curiosity
Mm.
could help us tease apart those times when we're genuinely intrigued by a challenge versus just feeling totally stuck or frustrated.
Right. Like, is it curiosity or is it just I'm lost?
Exactly.
Yeah.
And to really understand this, they break down curiosity into three main ingredients.
Okay.
And these aren't specific to math,
Uh-huh.
but we're going to look at how they show up
Yeah.
in that world of numbers and equations.
Okay.
So the first one is what they call knowledge gaps.
All right. So knowledge gaps.
Yeah. Let's unpack that a little bit for the listener.
Yeah, so a knowledge gap is basically that moment when you realize, hey, there's something I don't quite get here.
Right.
But the important part is that you also have this sense that you could understand it.
Uh-huh.
It's not just like, oh, I'm lost forever.
Yeah, it's not a feeling of giving up.
Right.
It's like, what
It's
if
a solvable mystery.
I think I can get this?
Right.
Yeah? And in math, this could be something as simple as seeing a formula and being like, oh, I don't remember that.
Right.
Or it could be something more intriguing, like noticing a pattern
Exactly.
and wondering, why does that pattern exist?
Yeah, like what's the underlying,
Yeah,
what's going on beneath the surface.
totally. Yeah.
So it's that awareness of a missing piece, but with the feeling that you have the potential to find it.
Okay.
The second ingredient is heightened arousal.
Okay. When I first read that, I was like, wait, what?
Right. I know it sounds a little
That sounds a little intense.
a little alarming. But they're not talking about like a negative, anxious feeling. It's
Yeah.
more like that buzz of excitement you get, that
Right.
focused energy,
Right.
or maybe even a little bit of restlessness
Okay.
that kicks in when you hit that knowledge gap.
Yeah.
It's what makes you lean in and want to figure things out.
Right. Like when you're working on a math problem.
Exact-
And you're like so close to getting it.
Yeah, and it's almost like right there, and
Yeah.
you're like, I just gotta.
You can almost taste it.
Right, right. It's that feeling.
Yeah.
And it's a good feeling.
Yeah. Yeah, it is.
It's a
A
motivator.
driving force.
Exacto.
Okay, so that's heightened arousal.
Heightened arousal. All right, so we've got knowledge gaps.
Right.
We've got this heightened arousal.
Yeah.
And the third piece of the puzzle is exploratory behaviors.
Okay, and this one seems pretty straightforward.
Yeah, this is just what you do when you're curious.
Right.
You ask questions, you try different approaches,
Yeah.
you tinker, you play with the ideas.
You're like, let me just mess around with this and see what happens.
Exactly. And in math, this might look like working through a problem a couple different ways to see if you get the same answer.
Right.
Or even just asking yourself, like, what if I tweak this one thing? What happens then?
Yeah, just kind of poke and at it.
Right, exactly.
Yeah.
So we've got these three things.
Okay.
Knowledge gaps, heightened focus or that arousal,
Yeah.
and then that urge to explore.
Urge to explore.
So now we can really dig into how this might work
Okay.
in the specific context of mathematics.
All right, so let's bring it to math.
Yeah, let's math it up.
Let's math it out.
So let's start with those knowledge gaps in math.
Okay.
Like, how does what you already know about math shape what you even notice you don't know?
Yeah, that's a really good question because it seems like
Right.
if you think that math is just a bunch of rules you have to memorize,
Mm-hmm.
then the only knowledge gaps you'd be aware of are like, oh, I forgot that rule.
That's a really key insight. And The article really highlights this.
Yeah.
As your mathematical understanding grows, both in terms of like the concepts and how you can actually work through things,
Right.
the knowledge gaps that catch your attention, they get more sophisticated.
Okay.
You might start noticing gaps in how different mathematical ideas connect to each other.
Right.
It's almost like seeing the hidden architecture underneath things.
Yeah, like the connections between things.
Right, like realizing, oh, wow.
Yeah.
The concept of like rate of change shows up not just when you're calculating speed, but also when you're tracking population growth. And even in like the fancy world of calculus.
Yeah. It's all connected.
It's all connected.
Yeah. Okay. So it's like
you've got.
once you have a few pieces of the puzzle,
Right.
you can start to see where the more interesting missing pieces are.
Exactly.
Okay. Now, the article also talks about this
Yeah.
inverse U function of curiosity.
Yeah.
Okay. That sounds a little...
It's a fancy term.
Yeah. What does that mean in plain English?
So the basic idea is that your curiosity in math isn't necessarily highest
Okay.
when you know absolutely nothing or when you feel like you've mastered everything.
Okay.
It actually tends to peak when you have some foundational understanding,
Yeah.
enough to realize that, oh, there's something big here that I don't quite grasp.
Yeah.
If you're starting from absolute zero,
Right.
you might not even know what questions to ask.
Yeah. You don't even know what you don't know.
Exactly. And if you think you know everything,
Right.
well, then there's no mystery.
Yeah. Nothing to be curious about.
Right? There are no gaps.
Yeah.
So it's like this sweet spot.
Okay. So you got to know a little bit.
You got to know a little bit to be curious.
To be really intrigued. Yeah.
Okay.
Yeah.
Now, the article also touched on how what students believe about math
Right.
can actually impact how curious they are.
This is huge.
Yeah. How does that work?
Well, it makes sense, right?
If you think that math is just a fixed set of rules
Uh-huh.
handed down by some authority figure.
Right. Like it's just in the textbook and that's it.
Right. It's in the textbook, the teacher tells you.
Yeah.
You might not be very curious about why those rules are the way they are.
Right.
Or if there are other ways of looking at things. Your curiosity might just be limited to like, how do I apply this rule correctly?
Yeah. Just get the right answer.
Just get the right answer and move on.
Yeah.
But if you see math as this more dynamic, interconnected system
Okay.
of patterns and relationships that you can explore and build upon yourself.
Right. Like it's something you can play with.
Exactly.
Yeah.
That opens up way more possibilities
Yeah.
for knowledge gaps that can spark your curiosity.
Right. Because you're not just looking for the one right answer.
Exactly.
Yeah. You're looking at all the connections and all the different ways of looking at something.
Yeah, it's like the difference between just wanting to know the answer to a problem
Right.
versus understanding the principles behind why that answer is true.
Yeah. And how it connects to other things.
And how could this apply in different situations?
Yeah. Wow.
Right, so it's a much richer kind of curiosity.
Okay. And so building on that,
Yeah.
the article also highlighted the importance of recognizing and valuing mathematical patterns and relationships.
Right.
How does that play into math-specific curiosity?
This is really key, you know?
Yeah.
In everyday life, we tend to look for cause and effect relationships.
Right. Like this happens because of this.
Right.
Yeah.
But mathematical patterns and relationships can be much more abstract.
Okay.
And developing a curiosity for these more abstract connections is a hallmark of mathematical thinking.
So it's not just about like what's the practical application of this.
Right.
It's about seeing the beauty in the connections.
Yeah, it's about seeing the elegance and the structure,
Okay.
even if it doesn't have an immediate, like, tangible outcome
Yeah.
in the real world.
Like appreciating a beautiful proof.
Exactly. Even if you're never going to use it to build a bridge.
Right, exactly. It's like appreciating a spider web.
Yeah.
Even if you're not an entomologist.
Right.
You can still marvel at the beauty and the intricacy.
Yeah, and the patterns.
Right.
Yeah.
So it's a similar kind of appreciation.
Okay, and that reminds me of those moments in math where you suddenly see how two things that seem totally unrelated are actually connected. And it's like, whoa,
It's mind-blowing.
it's so cool.
Yeah.
Yeah.
So that's definitely a part of this math-specific curiosity.
Okay, now one last point
Yeah.
in this section that stood out to me was the impact of time and effort expectations in math education.
Right.
How does that affect whether someone actually gets curious?
This is huge, especially in today's world,
Yeah,
because students are often under pressure to get quick solutions
right.
in math, both in the classroom and on standardized tests.
Right.
They might be less likely to really invest the time and effort.
Yeah, that's needed to explore those bigger, more complex knowledge gaps
Right.
that could lead to really deep curiosity.
It's like if you only have 5 minutes to solve a problem,
Exactly.
you're not going to ask the bigger questions.
You're not going to go down those rabbit holes.
Yeah.
You're just trying to get to the answer.
Just trying to get the points.
Right. And that's a shame because that's where the real curiosity can blossom.
It's like you're trying to appreciate a symphony,
Right.
and you only have 30 seconds to listen to it.
You're going to miss
You miss the whole thing.
all the nuances.
Yeah. Okay, so that totally makes sense.
Yeah.
It's hard to be deeply curious about something if you feel like you're constantly being rushed.
Absolutely.
Okay, so let's move on to the second ingredient
Okay.
of curiosity.
Yeah.
That feeling of heightened arousal in math.
Right. Heightened arousal.
Yeah. How does that actually show up?
Well, it's really fascinating how our minds and bodies react. When we encounter something mathematically intriguing,
Right.
you might notice an increased sense of focus,
Okay.
a heightened alertness,
Yeah.
maybe even a little bit of that mental restlessness.
Like a little bit of an itch.
Yeah, like I got to figure this out.
Yeah.
Now, the important thing is whether you interpret these physical and mental cues as curiosity, which is that positive drive to learn and explore,
Yeah.
or as something negative,
Right.
like confusion or anxiety.
So it's almost like how you label the feeling.
Yeah, exactly.
Yeah,
It's like, is this excitement or is this fear?
Yeah.
Am I feeling energized or am I feeling overwhelmed?
Right. Right.
And that's where the control value theory of achievement emotions comes in.
Okay, so control value theory of achievement emotions.
Yeah, it's a mouthful.
Yeah, break that down for us.
Basically, what this theory says
Okay.
is that how you feel in situations where you're trying to achieve something, like when you're tackling a math problem,
Right.
is really influenced by two things.
Okay.
One, how much control you feel like you have over the situation.
Okay, so like I can do this.
Right. I can handle this.
Yeah.
I'm not totally lost.
I got this.
Right.
Yeah.
And the second thing is how much you actually value the subject matter.
Okay, so if you actually care about math.
Right. If you see the point.
Yeah.
If you're interested. So if you feel a sense of control
Oh.
when you're faced with a math challenge and you see some value in understanding it,
Right.
you're way more likely to interpret that heightened arousal as curiosity.
Okay.
Like, oh, this energy is pushing me to learn.
Yeah.
But if you feel totally lost or you don't see the point of the math at all.
Yeah, why am I even doing this?
Exactly.
Yeah.
Then that same heightened arousal
Mm-hmm.
can turn into frustration or anxiety.
Right, because it's just unpleasant energy.
Yeah, it's like, I don't want to be here.
Yeah.
I don't know what I'm doing.
I'm stuck.
I'm stuck and I don't care.
Yeah.
Right? So that's not a good place to be. Right.
So it's like if you have the tools
Right.
and you understand why it's worth the effort, then that energy can actually be positive.
He can be fuel.
Yeah.
It can drive you forward.
But if you feel helpless
Right.
and you don't know why you're even trying,
Yeah.
it's just going to feel bad.
It's just going to feel like pressure.
Yeah. Okay.
Now, one thing the article pointed out is that students' perceived competence in math
Okay.
often decreases over time.
So they start to feel less confident.
They start to feel less capable,
Yeah.
and particularly in math.
Particularly in math. Yeah. And this is interesting because
Yeah, why math especially?
I think it has to do with how math is often taught.
Right,
It can feel very black and white.
right. Like there's only one right answer.
Right. There's only one right answer.
And if you don't get it,
You're wrong.
you're wrong.
And that can be really damaging.
yeah, it doesn't leave a lot of room for exploration.
It doesn't, and it doesn't build confidence.
Right.
So anyway, as students' confidence declines,
They're more likely to experience that heightened arousal as frustration
right,
rather than as that spark of curiosity.
because they're like, oh no,
Right.
this is another thing I'm going to get wrong.
Exactly. And that feeling of, I'm not good at this,
Mm-hmm.
can really shut down any willingness to engage or explore.
Right, because if you already think you're bad at it,
Right.
then why even try?
Right. Why even bother?
Yeah, it's like that snowball effect.
It is. It's a vicious cycle.
Yeah, the less capable you feel,
Uh-huh.
the more anxious you get
Mm-hmm.
when you face a challenge.
Right.
And then that makes you less likely to be curious and want to learn more.
It just feeds on itself.
Yeah. And then the article also touched on how our understanding of emotions develops
Right.
as we get older.
Mm-hmm.
And I thought that was interesting.
Yeah.
How does that relate to recognizing curiosity in math?
This is subtle, but it's really important.
Okay.
So, for example, younger kids
Yeah.
might have a harder time distinguishing
Okay.
between different emotional states. So that feeling of heightened focus when they're faced with a math problem,
Right.
It might just feel like a bad feeling.
Yeah. It's like, ugh.
Right, because it's intense.
Yeah.
But they might not have the vocabulary or the experience to label it as curiosity.
It's just like, oh, this feels hard.
This feels hard.
And I don't like it.
Yeah, I don't like it.
Yeah.
But as we mature, we get better at understanding and differentiating our emotions. And that can help us see that spark of curiosity for what it is.
It's not just bad. It's like,
it's an opportunity.
it is interesting. Yeah. So maybe as we get older, we get better at recognizing that feeling of almost getting it as genuine curiosity instead of just frustration.
Exactly.
I like that.
Yeah.
All right, let's move on to the third key ingredient.
Okay, the third one.
Exploratory behaviors in math.
Exploratory behaviors.
Yeah, so how does curiosity actually drive us to ask questions and explore in this world of numbers?
Well, curiosity is a powerful engine for seeking out more information and deeper understanding. And in math, as your interest in a topic grows, you naturally start to ask those deeper why questions. You're not just satisfied with the answer. You want to understand the reasons behind it, the connections to other ideas, the bigger picture.
The why of the why.
Exactly, the why of the why.
Yeah.
And that's where things get really interesting.
Okay, now you mentioned that different teaching approaches can either encourage or discourage this kind of question asking and exploration.
Huge point.
And can you tell us a bit more about that?
Yeah, so if math class is mostly focused on rote calculation and memorizing procedures,
just like plug in the numbers.
There's not a lot of room for those open-ended why questions or for exploring different ways of thinking about a problem.
Right. It's just about getting the right answer.
It's about following the steps. But if the focus shifts to problem solving, to encouraging multiple approaches, and to really valuing the process of discovery, then that sense of curiosity and exploration, it naturally blossoms. When you're encouraged to tinker and try different things, your curiosity has room to grow.
Right, because you're not afraid to be wrong.
Exactly. It's a safe space to explore.
Okay, so it makes sense that if you're just constantly doing the same type of problem over and over, there's not much room for you to be like, what if I did this other way?
It's like you're on a treadmill. You're just going through the motions. You're not really exploring.
Now, speaking of exploration, the article also brought up the role of proofs in math as a form of exploration.
And this is interesting.
Yeah, because I think a lot of people find proofs really intimidating.
Yeah, they can be.
Yeah.
But what's fascinating about proofs is that they are at their heart a form of mathematical exploration. It's about logically demonstrating why something is true, uncovering the underlying structure and the reasoning. However, if students see proofs as just like this rigid set of steps that they need to memorize,
just to get the points.
Just to please the teacher, rather than as a flexible and creative process of discovery, it can really kill their curiosity.
Like we bother.
It becomes a chore. But when proof is presented as a way to understand why a mathematical statement is true, and students are encouraged to explore different ways of constructing those arguments, it can be incredibly engaging and a real driver of curiosity.
So it's about reframing what a proof is.
It's about the mindset. It's not a hurdle to overcome. It's an adventure in logical thinking.
It's a journey.
Okay,
I like that. So the article also linked what are called epistemic beliefs, which are basically our beliefs about how knowledge is acquired.
Like where does knowledge come from?
To the types of exploratory behaviors we engage in. So can you explain that connection a little bit?
Of course. So if you believe that mathematical knowledge is just handed down by authorities like teachers or textbooks, you're more likely to just direct your questions to those sources.
So you're not going to try to figure it out yourself.
Exactly. You're going to be
You're just going to ask the teacher.
Can you just tell me the answer? And that's fine. Sometimes that's appropriate. But if you believe that knowledge is something that you construct yourself through reasoning and experimentation and investigation, you're much more likely to engage in your own independent exploration. You're going to try things out, test hypotheses, see where they lead.
You're going to get your hands dirty.
You're going to get your hands dirty with the math. And that's where the real learning happens.
So it's about whether you see yourself as a passive recipient of information or an active builder of understanding.
Right. Are you a sponge or are you a builder?
I like that.
Yeah.
Okay. Now, the article also mentioned this idea of epistemic competence.
Epistemic competence.
What is that?
So in this context, it basically means developing proficiency and expertise within mathematics.
So getting good at math.
Yeah, getting good at math. And as you become more mathematically proficient, you develop a better understanding of the landscape of the subject. And this allows you to recognize the value in different types of questions and explorations. You can appreciate both the quick aha moment of solving a straightforward problem and the deeper satisfaction that comes from grappling with something more complex. Your curiosity becomes more nuanced and sophisticated as your understanding grows.
It's like the more you know, the more you realize you don't know.
And the more you can appreciate the different layers of curiosity. So it's like becoming a connoisseur of curiosity.
Oh, I like that.
Right.
A curiosity connoisseur.
Yeah.
Okay, so it's like as you get better at math, your curiosity about math can actually get more sophisticated too.
Exactly. It's not just about knowing more facts. It's about knowing how to ask better questions. And how to explore those questions more deeply.
Okay, now speaking of asking better questions, the article gave some examples of teaching approaches. Like problem posing. And resources like Open Middle. That are designed to actually cultivate curiosity. Can you tell us a little bit about those?
Yeah, so these are great examples of how educators are trying to tap into students' natural curiosity. So problem posing, for example, it encourages students to come up with their own math questions based on a situation or concept.
So instead of just being given a problem to solve, they're coming up with the problem. And this is really powerful because it puts the student in the driver's seat of their own learning. And it directly connects to their own curiosity. Yeah, because it's like, what are you curious about? Let's make a problem about that.
What do you want to explore? Let's turn that into a math problem. And then open middle problems. These are kind of cool. They're designed to have a single correct answer. But there are multiple ways to get there. So you might have the same starting point and the same end point, but there are all these different paths you can take to get there.
So it encourages you to be creative about how you get to the answer.
Exactly, and to explore different strategies and to think outside the box. So both of these approaches, problem posing and open middle, they move beyond just finding the right answer. They encourage you to ask the right questions and to explore different paths to get to that understanding.
So it's not just